This is a video lesson for secondary math, lesson 11-1. This is part 1, and we will be doing properties of exponents. So to review some things that we already know about exponents, going over the warm-up, number 1, it says to simplify using exponents. And so you learned before that if you have m times m times m times m, we can write that as m to the 4th power. And then n times n is n to the 2nd power. So the shorter way to write that expression is m to the 4th, n to the 2nd. Number 2, I've got v times v times v, so that's v to the 3rd. And then x, and I've got 5 of those, so x to the 5th, and then z to the 2nd. Usually when we write expressions like this, we'll put the variables in alphabetical order. Number 3, write without exponents. So what we're going to do is do the opposite. We're going to do what's called expand. So c to the 4th would look like that, times d, and then times f to the 2nd. Number 4, r to the 2nd, v to the 6th, w, x to the 3rd. Number 5, this question is to help you distinguish between addition and multiplication. And if it says x plus x, think about it, if you have an x and you have another x, you actually have 2 x's. Number 6, on the other hand, what is x times x? And so that one is like a picture of a square that measures x by x, and so what you have is x to the 2nd power. So just to make sure you understand, there is a difference between x plus x and x times x. Okay, for this lesson, just going over a couple of things, some words that we need to know about. So when we're talking about exponents, we have the base and the exponent. So the base is the factor that's common, so what's being repeatedly multiplied. So if you have 5 to the 3rd power, then 5 is our base because it's 5 being repeated, and then the exponent is 3 because it's being repeated 3 times. So 5 is being multiplied by itself 3 times, or we say it is used as a factor 3 times. Okay, properties of exponents. These are some rules. And they're good to know, but it's not absolutely necessary. If you write things out, if you are able to write things out, then you don't really need to memorize these, but they're things that people notice. So the first one, when multiplying numbers with the same base, you would add the exponent. So for example, x to the 4th power, if I write this out in expanded form, times x to the 3rd, then that's going to be x to the, you've got 4 and then you've got 3, and so that's going to be 7. And so you can remember that, or you can write it out. When dividing numbers with the same base, you're going to subtract the exponent. So if I have x to the 5th over x to the 2nd, then we know from previous experience that if I have x divided by x, that's 1. And so what I'm left with is x to the 3rd power. Now I could have gotten that by saying x to the 5 minus 2, but I personally like to just write it out for especially that rule. The next one, to find the power of a power, you're going to multiply the exponents. The reason I'm not such a fan of all of these rules and like just memorizing the rules is because it's really easy to get it mixed up. And so I find that it's really good to know that you can have a backup plan of writing all of this out. And so if I write x to the 3rd to the 4th power, I'm writing x to the 3rd, and I'm going to do that 4 times. And so when I get all done, I'm going to have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I could get that result by just saying 4 times 3, but here again, it's kind of hard to remember. Do you add the exponents, subtract them, multiply them? So I just try to avoid that if I can. The last kind of rule that you need to know is that any number to the power of 0 equals 1. So 5 to the 0 power is 1. That's kind of hard because a lot of people want to say that it's 0, but it's not. It's 1. There's reasons why, but you can just know that x to the 0 is 1, 5 to the 0 is 1. If we've got this quantity in parentheses to the 0 power, it's 1. Now if the parentheses weren't there, then that would be different. If I had 12x to the 3rd, y to the 5th, z to the 0, then the only part of that that's 1 is this part. So I'd have 12x to the 3rd, y to the 5th times 1, which would be that. So if the parentheses weren't there, that's how it would be. Okay, we're going to start this lesson by simplifying using our laws of exponents. So those rules we just went over. Like I said, I personally am not a huge fan of memorizing the rules, but doing it enough that you understand how they work kind of does the same thing. So number 1, it says 5x to the 7th, and so if I write that out, times negative 4, x to the 3rd, what you're going to do is you're going to take the 5 times the negative 4, and then you're going to take x, that's your base, and you're going to count up how many times you have it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's your answer. So you could have done that by adding the exponents of 7 and 3. And if you remember how to do that, then that's fine. If you get mixed up or you forget what the rule is, then you always have this backup plan. Okay, number 2, 4a b to the 6th times negative 7 a to the 2nd b to the 3rd. So I'm going to take my 4 times my negative 7. I'm going to take a, and so a to the 2nd, I actually should have written that as a times a. So I'm going to have a times a times a, so I'm going to have a to the 3rd. And then for my b's, I'm going to have b to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how you simplify an expression using your rules of exponents. Number 3 is a little bit different, just because there could be parentheses around that, but since we didn't write them, we just kind of have to think about it differently, I guess. So 3y to the 4th times 7, and then y to the 5th. So I'm going to take the 7 times the 3. So it actually doesn't make any difference if you've got the parentheses in an expression like that. You're going to have a total of 9 y's, so it's y to the 9th power. So hopefully problems like that are familiar to you. You've done problems like that before. And so you're just, if you write it out the long way, then that will always help you. Okay, continuing on. This one you've got parentheses around both pieces of it. So you can, if you're starting to get the hang of the rules, you can do that. So you can say like negative 4 times negative 6, that's positive 24. And then you've got r and r to the 5th. So if you remember what the rule is, you can go ahead and write what the answer is for that part. But if you don't, then you can say r and then r to the 5th. So that's going to be r to the 6th power. Then you're going to do the s's. You've got s to the 2nd, s to the 2nd. So that's going to be s to the 4th power. Y to the 3rd, y to the 0. Remember that y to the 0 is just going to be 1. So y to the 3rd times 1 is just y to the 3rd. Number 5, this one is different because we've got stuff inside and then it's being raised to a power. So this is our power of a power one. And so what we're going to do here is you're going to take what's inside, so the 3y to the 2nd, and you're going to write that 4 times. And so you would do 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. And then y is your base, and you've got 1, 2, 3, 4, 5, 6, 7, 8 of them. Number 6 is like that, so pause the video and do number 6, and then see if you've got it right. What you should have done on number 6 is think about it like this. And so you're going to have negative 5 times negative 5, which is 25, and then times negative 5, so it's negative 125. Then you're going to have m times m times m, and then you're going to have n times n times n times n times n times n. Number 7, same thing, power of power, so pause the video and try this problem. You can see that it gets a little bit tedious to write out this many exponents, and especially when you start writing something this long 4 times, that's a little bit of a pain, and so that's why the rules come in handy. So if you're starting to get the hang of that, you do not have to write all of this out. However, it is something that people do get mixed up on, because the thing that people want to do that's wrong is they'll do negative 2 times 4 and they get negative 8, and that's not right. Because what you're doing is you're doing negative 2 times negative 2, which is 4, times negative 2, which is negative 8, times negative 2, which is positive 16. And so you have to be really careful about that you're not doing the wrong things. X to the 2nd to the 4th power means x to the 2nd 4 different times. So that's x to the 8th power. And then y, and I've got 4 of those. And z to the 3rd, I've got z to the 3rd, z to the 3rd, z to the 3rd, z to the 3rd. So that's z to the 12th. Okay, now looking at these problems a little bit differently, we can look at this as a shape problem, an area problem, because that's really what square numbers are, they're areas. And so remember that the area of a square is base times height, and in a square, the sides are the same length. So this side is also AB. So to find the area, you're going to take one of the sides, and you're going to raise it to the second power, or you could have written that as 4AB times 4AB. So either way, you're going to end up with 16 because that's what 4 times 4 is. Remember, don't do 4 times 2. That's not correct. And then a to the second power, b to the second power, and that's in feet squared. The reason it's in feet squared is because if you do 4ab feet times 4ab feet, you're going to have 16a squared b squared feet squared. Okay, number 9, the area of a triangle. Here's the formula for the area of a triangle. So the area is equal to 1/2. The base of this triangle is 4a squared c, and that's in meters, and then times 6ac to the third, and that's also in meters. So really what I've got to remember here is I'm going to do meters times meters. So my answer is going to be meters to the second power. On something like this, you can take the 1/2 times the 4 times the 6, and it doesn't matter which one you multiply by 1/2, but just do one of them. So you can do 1/2 times 4, which is 2, times 6, and get 12. Or you could do 1/2 of 6, which is 3, and then times 4, which is 12. Or you could even do 6 times 4 is 24, and half of that is 12. So either way, the 1/2 times 4 times 6 is going to be 12. And then you're going to have a times a times a, c times c times c times c. And so that's the area of the triangle. So if I know what a and c are, I could actually find a number to come up with, but this is just in terms of a and c.